The mission of the Advanced Transportation Division is to enable industry to bring clean energy technologies to market. So we support them to develop clean, efficient, cost-effective solutions, whether that is energy storage, advanced vehicles, vehicle-to-grid, or even biomass. A lot of the work that we do here really is to enable electrified vehicle transportation. What's unique here at INL is the ability to test various batteries and vehicles at various scales. What we're able to do is we can test batteries from as small as a coin, like in your watch, all the way to a full vehicle battery pack. And as a national lab, we're very unique in that capability of testing batteries at various scales. From a vehicle perspective, the EV infrastructure lab and its capabilities of testing wireless charging, level 1, level 2, and DC fast charging simultaneously is a very unique capability at INL.
The Advanced Transportation Division at INL supports DOE's overall goal of reducing petroleum consumption and increasing the nation's energy security. We do that through systems integration, demonstration, and development of automotive technologies and the infrastructure that supports those technologies, such as electric vehicle charging equipment. The Electric Vehicle Infrastructure Lab, or the EVI Lab as we call it, is a new lab that provides the capability to test conductive and wireless charging equipment. What's exciting about the lab is we not only perform tests on the individual pieces of equipment, but we can connect the equipment to vehicles as well as simulated distribution level electric grids and the actual microgrid here at INL, and understand how the vehicles perform under varying grid conditions.
The Electric Vehicle Infrastructure Laboratory has an extensive capability in testing wireless charging as well as conductive charging systems in an in-depth aspect in terms of, for wireless charging, coil misalignment, coil gap, as well as efficiency and power quality, and even cybersecurity aspects of these charging infrastructure technologies. Cybersecurity vulnerabilities are being researched and mitigated to prevent issues with respect to mobility and cybersecurity. Some of the real-world impacts are electric vehicle adoption by consumers, as well as true efficiency improvements, reducing petroleum consumption through electrification of transportation.
I'm the Energy Storage Group Lead. I'm really responsible for overseeing what occurs in the Battery Test Center. The Battery Test Center is really focused on advancing battery technologies, and we primarily work with the Department of Energy and the United States Advanced Battery Consortium, or USABC. With those two entities, what we really do is we take deliverables from programs and evaluate whether or not they'll actually function for a specific application within the light-duty vehicle fleet. We've really focused on one of the key problems that comes up, or that is often raised with electric vehicles, of whether or not the method of charging is actually going to impact battery life. So as part of that study, we compared two different charger types, so DC fast charge and a level 2 charger, both in the lab and on the road. And with those, what we looked at is using standardized conditions that removed any external variabilities to actually understand if the DC fast charge, which is a much faster charge than the level 2 charge, is going to impact overall battery life. So when we did those in both in-lab and on-road, we found very little difference in terms of the aging of those two batteries. So over the course of 30 to 40,000 estimated miles, either on-road of actual driving or estimated in the lab, there's only a few percent variability between those two different systems.
The work we do is all about understanding the ability of in the real world of alternative fuel technology, and specifically electric vehicle technology, to meet customers' needs for travel and to reduce our nation's petroleum consumption.
I'm a huge car guy. I love cars. So the fact that I get to work on cars every day is really something that I feel very fortunate to do. The work we do here at INL and the Advanced Transportation Division is very important for a variety of reasons. The reality is a lot of these technologies exist. What we do here is really trying to make sure that the technology hits the market and the consumer accepts what we're trying to bring to market. If you think of it from a larger perspective, we're really trying to minimize climate change and reduce greenhouse gases, which is the ultimate goal of electrified transportation.